Welcome. Let's dive right into it. This talk is going to be really opinionated. Just to offer the initial advice for engineering perspective. Yet, just consider that it's not dogmatic, so everything is just up to discussion. It's not black and white. And it's based on my experience running a solo consultancy company for industrializing data science models and setting up big data infrastructures. This talk, as of now, is available at that URL that you can see. So, what this talk is about is you have a model and you want to put it to production. And there are a lot of conflicting goals coming from the business that you want to adhere to. You can see a list in there. And from the engineering perspective, adhering to all these goals can be really challenging. So what I want to show you is just a list of 20 best practices that I have come up with, which can help to deliver on these goals. And since the time is limited, let's dive right into it. So the very core principle, the first one, you have developed a model and you want to put it in production. Well, most importantly, don't build anything. Don't industrialize your code. Just buy an off-the-shelf solutions. There are immediate benefits to this, from rapid project delivery, minimal maintenance, and so on. You can all read it on the left side. There are vast ecosystem out there for SaaS solutions which you can reuse. For example, for ETL, data warehouses, for A/B testing, machine learning, and so on. So don't be afraid and try them out. It will save you a lot of time. However, if you really decide to go and build something, just start small, build it lean, build a very narrow slice of functionality, and then expand it. If you want to learn more about how to do this, there is a great book, Lean Startup, and also there is a blog post about the thirst of the quench, what developers have to, which drives them to implement solutions rather than reuse. So please read it and go this way. Well, however, if you decide to build something, then most important, how to collaborate and how to use Git. What I found is have at least 2 people always on a project. It encourages shared knowledge. You can rubber duck with an actual person instead of a duck. It increases the buzz factor, so if a person leaves, the knowledge is preserved in a company. The code quality is higher, and it prevents one-main frameworks and over-engineered solutions just by having more people in the team. If this is not possible, then at least add another reviewer to the project. All right, once you have a team, then just use Git. Use it as a platform for versioning, collaboration, and deployment. I think of Git as this centerpiece in all projects that the whole engineering and development revolves about. Using Git has great advantages. Just on the left side, they are listed there. What's also important, Git is, the usability can be improved, so it might be a bit unintuitive sometimes. What helps a lot is to invest in learning Git, use it from command line, understand the basic commands, and this really helps. Another one, once you have Git, then just require public and focused code reviews. There is a great quote from a boss from GitHub this year on DevOps. I will read it. When another person looks at your code and gives it the same level of attention like you did when writing it, your work gets better. Indeed, code reviews helps to catch bugs way earlier during the review process rather than when the application is in production. It helps to share the knowledge, and both the coder and the reviewer benefit from this process. How to do this? Just use dedicated feature branches which are short-lived for new features and fixes. Use pull requests and merge them only if they are reviewed and accepted by your reviewers. If you want to read more about how this works or how to do code reviews, there are 2 links below. All right, so now we have a code base. We have a Git and a team, and we need to write a code. What helps a lot is to have a clean code base. And I cannot stress this more enough. If I would have to pick just one principle to take out of this talk, is just this one. Apply clean code principles. It's just #1 most important engineering principle which everybody doing any coding should adhere to. Having clean code just drastically improves readability. It leads to faster bug detection and lower maintenance. I actually had in my university a whole semester about clean code. So there can be a whole conference or at least talks about this topic. What I really encourage you to do is grab the book, The Code Complete, and just read it. And this will make such a difference. Jeff Antwood, who is the founder of Stack Overflow, my developer idol, said that he has a list of books to recommend for each developer, and this is the #1 book. And he says that make this book the first you read and the first book you recommend to your fellow developers. I cannot stress this more. Just to select a very low-hanging fruit from this book, there are 2 main principles. Just don't repeat yourself on any level. If you have just the same literals within your Python code or one-line functions, if you have parts of the methods which are duplicated, just extract this logic and you will see that this principle is kind of elegantly driving your refactoring and leading to better code. Also, as touched in the keynotes, there's also duplication within the SQL and ETL part and in data preparation. So try to catch these and also just make it dry. Use it only implement it only once. Don't duplicate. And the second thing is just naming things semantically. So instead of having variables called data, just put some semantic meaning into them. For example, sensors instead of data. A reader immediately knows what is going on. And I have a few personal favorite principles. One is organizing code by features. I will not go into it. Take a look. So really, this is the absolutely most important principle when building something. I cannot recommend the Code Complete more. All right, and then another one is just prefer immutable, functional, and side effect-free code. David Pollack, who is a creator of Scala LiftWeb, has this great quote about functional programming. I will just read it. Immutable variables leads to thinking about alternative immutable functional code. That leads to new coding patterns. New coding patterns leads to a shift in your approach to programming. And this shift in approach leads to transformative code that has fewer defects and is easier to maintain. I always thought that functional programming is something to be used in Haskell and this academic languages. When I studied, the Haskell wasn't used in industry at all. And it took me a while to realize that what this functional approach really is. And it's not related to a language. You can write functional immutable code in any language possible. And I very much advocate to doing so in Python as well. If you want to know more about this, there is a great a course on Coursera by Martin Odersky, the founder of Scala, about the functional programming. It's language agnostic course, but you can get the basic idea what it means in there. Another one is use consistent code style. Oftentimes, when we don't do this, we are a code in low priority opinionated discussions, and we need to have a lot of small decisions. We need to do all small decisions while coding, and having a consistent code style helps to fight this and to lower decision fatigue. So please do. Another one, use consistent and semantic field names in your data frames and databases. This is such a huge time saver. So I often see you have a table with, what I want to do is just to have a quick understanding what a table or a data frame is about, and just applying a few simple principles, I'm able to do so. So I just pick two. One is to have a consistent naming. So for example, just a very simple one, just prefix all fields, all Boolean fields with is or has. That really helped. And another one is just add semantic meaning. So instead of having a column which is called timestamp, what is a timestamp? I know it's a timestamp just from looking at the data, but what does it represent? So for example, just replaced imported at or imported at instead of time. It immediately gives more information. What also helps is just to use a strict SQL schema and strong validity checks. What I mean that in the beginning of a project, try to have encode as much information into the database schema as possible, which will give the checks and also kind of implicit documentation about the data you are using. And you might find later that the check is too strict, so you can anytime loosen it back. Loosen it. The other way around, that doesn't work well. If you have a very loose schema and you want to make it strict, then you have to do a lot of additional work. Test your code, especially end-to-end. End-to-end tests are the killer ones, because what I have found is that end-to-end tests are typically short, brief, like concise, but they are so powerful. It enables to do refactoring of all the sub-units within a feature, and it tests the whole pipeline. So they are very elegant and, based on my experience, the way to go. And if in this pipeline you have a complex logic, just use unit tests to really bulletproof them. And one which is often forgot is also test your ETL and data quality. We are on a PyData conference. We speak about a lot of machine learning models, but what is below them is data. And having corrupted, incomplete data can lead to wrong results. So what I found useful is add checks, assertions in your ETL, and treat the ETL part as a real code, just as you would treat the code. All right, so you have a clean code base. Let's speak a bit about the just architecture and tooling. Keep architecture as simple as possible. I've seen this many times due to different reasons. Let's say what sometimes happens is the top management goes to a big data conference and they hear that they want to do big data and Hadoop. And they come back to the company saying, team, please implement Hadoop. So the team implements Hadoop. But maybe it's such an overkill to do it. And just be aware that that particular technology might be currently hyped and might be an engineering overkill to use in your particular situation. What I found is that just prefer simple batch jobs over real time and single host over distributed. And so start with batch, single host implementations and move to more complicated ones only if that is really needed. What this allows is also to grow your architecture organically based on problems rather than hype. For data persistence, also keep it simple. Just consider plain files or relational databases as a baseline, and deviate only if needed. As you can see, I'm a huge fan of keeping things simple. This also applies to persistence. Most data that I have encountered are not large, and have fixed schema. So why not use a tool which is perfect in this, which are relational databases. It has many features, powerful features that you can use. Of course, you might have a very special use case, and what you need is different from a relational database. But I just always takes, in this case, Postgres, my favorite one, as a baseline, and deviate from it only if the requirements call for it. Also, there is a great article at the bottom, the first tip. You probably don't need Hadoop. Just wonderful article. I very much recommend to read it. And I also recommend using Flyway, which is a SQL migration tool for reliable schema updates. If you don't know them, if you don't know it, please check it out. It's a really, really sweet tool. Regarding building your ETL pipeline, I have found out that there are dedicated tools which can simplify the jobs for you. For example, Apache Airflow and Luigi. You don't have to, the ETL, you have all these. If you build your own pipeline framework, it's not hard, but there are a lot of these small things you have to think about. And there are existing solutions for this, so please check it out, and it might be useful to you. Another one is just doing a dedicated job queue management tool for long-running, user-triggered computations. For example, salary and the APS scheduler. So for example, if you want to just trigger a task which would retrain a model or run an ETL, and it takes long, and it can be triggered multiple times from multiple administrators or end users, such tool might greatly help in implementing such use case. And the last part is DevOps. Set up push-button deployments. Martin Fowler, who is one of another idols for me, says that you should have ability to perform push-button deployments of any version of the software to any environment on demand. And once I came to a company, and there was the deployment process took, actually it was a manual. There was a manual for it. It has like 30 pages, I kid you not. And if you want to deploy a new version to production, you just have to pick up this manual and just read it through, and it took maybe a few hours just to deploy a change. So the first thing we did, we fully automated this and created a push-button deployment. It has many advantages to do it like this, to have a push-button deployments, because it encourages you. Well, first of all, you have to have. It removes friction, so you are kind of encouraged to deploy more often because it's so simple, and it completely changes your mindset once you have the deployment automated. What also helps is, regarding deployments, to have your code base backed by strong tests, so you have confidence to deploy often. And once you have these two things, confidence in your application and automated deployment pipeline, you are the king, really, because you can just you can deploy often, even daily or after each change, and your time to market lowers drastically while keeping the deployment risk low. I like the last bullet from the how section. Aim for boring, predictable, and frequent deployments. Another one, keeping the dev, test, and production environments identical. I see this many times, that there is you have a model which is developed. There is a data scientist working on Windows using some kind of using a binary solver, let's say, which is installed on a system. Then I work on my Mac, and the application is deployed on a Unix machine. So there are 3 different operating systems with 3 different compiled binaries. There are many times I see that there is this work on my machine problem, and you can eliminate this. There are tools to eliminate these kind of problems. They're typically provisioning tools where you can choose an operating system, install system dependencies, and Python dependencies, and have the same environment across on my local machine and on production. Apart from removing this work on my machine, it also implicitly documents the system requirements, which is always very helpful. It also helps in running integration tests in your continuous integration platform. And it also helps to create just one button setup for local development environments. So if you have this setup, what typically then means that you can have a new developer coming to the team, and he just do git clone and the Docker Compose up, and he has the whole application, including system dependencies, databases, Redises, and whatnot, up and running with one command. My favorite is Docker. For those of you who don't know Docker, there's just a very quick example of its power. On the left, we see a Docker file when you defined where your Docker image, which is kind of like a very lightweight virtual service, very lightweight though, a virtual machine. You define from which base image it derives from. In this case, I chose Python 3.6, which again derives from, I think, Debian. You can install, you declaratively specify what needs to be installed on this base image. In this case, I have some solver libraries, and then I copy my application to this Docker image, and I run the requirements, and I specify that when I run this image, the command python predict.py should run. Once this is built, you can just kind of run this container. You can think of it as a process, but with encapsulated, with the whole operation system encapsulated within it. And you can just simply run it. You first build it with Docker build, and then you run an image with Docker run predictor. This is super powerful. If you don't know it, check it out. Another one is centralized runtime logging. If you log to text files, it might be okay, but you might find yourself that it's very cumbersome to analyze and cumbersome to access. I encountered both issues. And having a centralized server for logging helps a lot. If you use, let's say, the Elk stack, which is my personal favorite, you get a very easy access. You have Elasticsearch on the bottom as a database, and you push logs there via some log aggregator solution, let's say Logstash, and then Elasticsearch as a JSON database gathers the log messages, and then you have Kibana, which is a web UI on top of it, through which you can very easily explore, visualize, and dashboard your logging. I very much recommend it. It also has a custom REST API if you want to build a custom dashboards or some kind of sleek, sexy Slack integrations with Elasticsearch and stuff like this. Another one is use environment variables to configure an applications. What helps is if you treat your application as a black box. Docker is good for it because Docker enables you to do it like this. And you can take this black box and run it in any environment, your local machine or in production. It's the same black box, the same image. However, there are differences between environments, like, for example, database URLs and credentials. And what I found useful is to configure these particular environment-specific settings via system environment variables. This allows you to not touch the black box. Just set up the parameters from the outside via environmental variables and run it wherever you want. What is great about this is you can have the same image running in production And then for testing purposes, you can just run it locally with just a different environment settings. There's a great article about it at the 12-factor app. It's a collection of best practices used for developing web-based applications. And in particular, this section about environmental variables is greatly explained there. I also recommend to check it out. And the last one is just use Slack as your information and control hub. I cannot recommend this more. In Slack, it's really, if you don't know Slack, it's kind of like Skype on steroids, and it allows you to have plenty of sleek integrations. So what I typically, or within a team, typically set up is just to have notifications about new commits, new pull requests, about successful or failed deployments, about exceptions running, occurring in the runtime, some data checks about the ETL and business metrics and so on. And also, you can add commands to Slack, like for example, merging a pull request or trigger a deployment and stuff like this. Well, and that's it. 20 best practices. I hope it helps. Thank you.
Thank you so much. Do you have any questions? Yeah, we have questions.
Like this. Can you give the URL
You have to use?
to the slides?
Yes.
You had it in the beginning, but I didn't catch it.
Oh, it's also on the back. Oh, no, it's not here.
Thank you.
talks.marcel.is/
Cool.
PyData Workshop Conference 2017.
Another question?
It's there.
Okay.
Hey, great talk. As far as I understand, you use that in your life, right?
Yes.
So how do you manage secrets? Actually, I have a few more questions than the first one.
Yeah, secrets. Well, first of all, don't commit it in your application code, and this is, to me, the basic principle. What you can do is either store it in a dedicated Git repository with limited access, or you can use what I haven't talked about. Instead of environmental variables, use like configuration, dedicated services to store secret information, and then you have your application and you just ask for a credential from this service. You can use this if you have a more complex infrastructure.
Okay. Actually, we are using Ansible Vault to encrypt the secrets, but I'm just asking because I'm curious what other people use. Another question: does the Docker image contains models from machine learning?
Oh, this depends on the. I cannot tell. It depends on the use case.
Okay, but do you feel it's better to include it inside, or maybe store on some kind of shared volume? Because then Docker image, it's getting quite heavy to upload and download and so on. So,
from the engineering perspective, I would always advise. I would advise to put a model in a Docker image because it encapsulates. It's like a. I have this. So it's like a black box with the whole operating system and Python dependencies, and it runs the same on all environments. So from this perspective, put it in a Docker image and relate it to. If the image itself would get large, there are workarounds around this. You can use, for example, smaller base images. You don't have to have a Docker image based on the whole Debian distribution. You can use Alpine, for example. An Alpine Python image is like 5 megabytes. So no issue there as far as I'm concerned. I think I haven't, bisect, yeah. I don't know how it's pronounced. I haven't, but colleagues of mine have. And the argument is that the argument of this slide was to just use Git because of all the powerful features and ecosystem around it. And plus, on top of it, it comes with advanced features which you might find useful in the future. And bisect is one of it. Yep. There is one more.
Works? Yeah. One more, but this is the last one.
Do you have any experience working with Engard or Feature Forge for checking the ETL on pandas, let's say? There's 2 projects for sort of testing in production, let's say, ETL. Let's say you're going to have some distribution of data coming in. Your model assumes it, but you never implicitly check it. So do you like assert it, or you have any experience using maybe those Engard or Feature Forge?
I haven't, but let's speak after, and I'm curious to learn about them.
All right.
And then I will add it to the slides.
Okay. Thank you so much for your talk.
Thank you.